We're going to welcome up Houman Shadab. He's to talk about the zero-knowledge economy. The question he's going to be asking here is, will you be incorporating zero-knowledge work into your application, and how? So please welcome Houman to the stage.
All right, thank you so much for the introduction. Thank you for the organizers for having me here. I've spoken at the International Monetary Fund, Consensus, that big conference, but this conference, in some ways, it's much more important and significant given the community aspect of it, and thank you for the organizers to putting it together. I think it's very important. This is how good work gets done and good people meet each other. So yeah, my name is Houman Shadab. I'm a co-founder of ICME, along with Wyatt Benno, who's out there somewhere. Oh, there he is. I can't see him, blinded by the lights, but we'll get more to that later. And so yeah, the title of my talk here is the zero-knowledge economy, in reference to this idea of zero-knowledge proofs, and this new wave of cryptography or encryption technology that's been around, of course, for decades. Like most cool things have been around for a while, but really starting to become more popular. Not yet mainstream, but that's what we're here to do, right? And that's what it's in reference to. And maybe one intuition behind this is that all of us have private thoughts, and we can speak to people without sharing our innermost thoughts. We can get dressed in the morning without necessarily knowing the process of that and knowing everything you're wearing right underneath. So there's this idea that there's this layer of things you don't share, and there's benefits to doing that. But when the digital world, in the current economy, in the digital economy, I think we're sort of oversharing, if you will. And that's what the zero-knowledge economy is trying to prevent and improve upon. So just this sort of idea to float out there about the zero-knowledge economy, a better way of doing things online, is that it's first completely integrated and completely private. So what does this mean exactly about completely integrated? What's an integrated economy? Well, it goes to the idea that we hear a lot about is basically end-to-end transparency, right? In supply chains, people say the ultimate goal is to know where everything is at any given point in time. Any cargo vessel, any change in the weather that may affect the location of cargo vessels and so forth. If a butterfly flaps its wings in one part of the world and that affects the route of delivery or the pricing of something, that can be updated in real time and be connected. And so yes, that is a great, valuable thing. The more things are connected and transparent and public, and I don't think I need to tell this audience the benefits of making things transparent and public and real-time interconnected. And one way to do that, of course, is to put it on a network, a single network, or at least an interoperable network like a blockchain. And have you heard of the Internet Computer? Okay, it's a blockchain that probably is best suited for that purpose. And in terms of how does that happen? Well, there's value, okay, so economic value, business value, and that could be inherently digital. And so it's digital, perhaps tokenized. It could be digitized, so something that's physical has a digital representation, art, real estate, and so forth. And that's part of the tokenization idea that may go along with it, and why blockchains may be well suited for that purpose as well. Okay, so that's the integrated economy. Who can be against something like that? And putting it on-chain, I think, is another part of this story too, which is controversial perhaps, in part because things that are on-chain may not be so private, may not be private at all. But what if we can have everything on-chain and everything encrypted or everything private as well? And that's the second component, perhaps, maybe the missing piece. So everything private, or the private side of this, the fully private economy, could include technologies. So I don't claim to be the biggest expert on all the new types of cryptography technology, related to cryptocurrencies, of course. But two of the major pillars I see out there, and there's certainly others, or maybe go by different names, are zero-knowledge proofs and fully homomorphic encryption. And the idea behind these zero-knowledge proofs that we've probably heard of before, chains like Zcash, privacy blockchains, use this idea of, and it goes back to academic research, I think even in the 80s, that I can prove to you that I know a secret is one way to say it, that something is true, that I possess something or knowledge of something without telling you anything else but that fact. It could be, again, the fact that I know a password. I know how to get into a door. And then I can prove to you just by walking through the door without giving you the key, without giving you the password. And what's interesting about zero knowledge proofs, among other things, and that's kind of fun to go down the rabbit hole of ZKP, is that there are these really interesting schemes to essentially indirectly prove to you that I know this secret in order to keep that secret and just prove to you the consequence. And so in the literature, there's these really interesting conceptual puzzles and theories and analogies, like I've used so far, to say, here's what it looks like. And one of the main ones is the idea where there's a prover and a verifier. And I think Peggy, the prover, wants to prove that she can get through this door. And the verifier keeps asking her, well, if you go to one side, and you always come out the side A or B that I ask you to, if you do that 1,000,000 times, you must be able to go through the door, because it would be too coincidental, right, for you to be able to come out the side I ask you to every single time without getting stuck and without just knowing what I'm going to say ahead of time, or without coincidentally going down the right path. But in the ZKP arena, as you can imagine, these proofs are not just kind of mind puzzles and stuff, which are good motivating examples and good ways to describe this, but they're actually mathematical proofs and computationally intensive proofs, similar to how blockchain can be very computationally and resource intensive to do something over and over and over again to prove probabilistically, to be sure, but nonetheless with almost perfect certainty that you possess a secret, you know the password, you have the identity, you pass the check, you're in compliance, whatever the use case is, without showing me any other data. So that's kind of the cool part about it. And I think as a community, to talk about community, it's good for us to, I think, to learn these analogies, to be able to explain in as simple terms as possible, get accurate, to other audiences, what is this really all about, in addition to making blockchain maybe better, because a lot of these technologies are used, especially ZKP, to make blockchain faster and more scalable and more private. And the idea here is that the privacy angle is that you can have smart contracts that don't reveal all the data about the transaction, or even as much as they do, which is not entirely transparent, to be sure. Fully homomorphic encryption, as a kind of another pillar of this, regardless of how we describe any particular technology, the idea is that you can run and work with and compute encrypted data. And so that's almost magical too, right? And that's obviously very technical, but the idea is that you can take data in encrypted form in a database, let's say, and run mathematics, run a function on it, and get your results. So the idea here is on the left, the cloud there is the processing, the function, the compute, and out pops the result, which can be unencrypted. And the idea is there is like now companies can work together and not have to worry about sharing data. And from a legal perspective, did I tell you all I'm a lawyer also? So watch out. Now, the idea is that you don't have to share data because there's massive, for example, privacy laws that must be complied with anytime you have personal data or confidential data from a contract's perspective, and you receive it or share it with other parties. But if you never receive the raw data, the plain text, essentially the confidential, the legally triggering data, in form that's legally triggering, you can still work with it. Perhaps another idea of fully homomorphic encryption is also your own database, right? One problem that cybersecurity tries to address is that people within a company stealing data, or people hacking into a company and stealing data within the company, not just data in the hands of third parties. So of course, if your own databases are encrypted every time you work with them, that could be another application too. But of course, FHE is quite costly and computationally intensive as well. Not the most efficient way to do things out of the gate, at least. And so what a private economy can do also is not just be made up of these pillars, but can combine them in really unique ways as well. So we can verify privately, for example, with ZKP, that your fully homomorphic encryption scheme is valid, and maybe the proofs can be public as well. And that's part of the blockchain angle, which can be, let's put these proofs on chain. or perhaps run the proofs or what they call circuits on-chain as well. So ZKP, if you're looking for a new area to come up to find interesting terms to use in everyday conversation, ZKP is a great one. You can say things like halo and plonky and be very, very serious about that. That was my attempt at humor. Okay, so why not share private data? Well, I think we all know the value of most of these things. Some of them are obvious, but we're in the knowledge economy, and even data like who are my customers, how do I do business, how do I price things, knowledge assets, if you will. We want to keep that private. Less obvious, I think, are cost and speed. Basically, the idea there is that if you can do something with sharing less data, it can be faster and can be cheaper. There's just less to process. I know you've done it. Thank you. I don't need to go through your entire database or see your entire process to know that you comply with something or your identity is valid from, let's say, a know your customer anti-money laundering perspective. At least a better automation, also better verification. So it's not just doing the same old thing privately, which by itself is a huge value, and itself is value enough for doing that, but it's also a better verification. So I can verify my age, I can verify my identity using ZKP, but in a private way, so I can tell you I'm an adult without telling my exact age, which is 32, by the way. But I can fake an ID, right? You can fake your age, you can fake and hack perhaps centrally controlled data more than decentralized ones, but ZKP provides better verification, or at least possibly, than standard, let's say, government-issued IDs, or name your ID system or what have you. And that leads to people are more willing to cooperate if they don't have to share as much information from a business perspective, perhaps, and other privacy-protecting purposes, and new business models, okay? If you're thinking about the profit perspective, the revenue generation, the new forms of cooperation, it's like, yeah, we can do business in ways we haven't done before. We can maybe come up with new business models entirely if we can interact much more privately and do it at scale as well. So just a few examples here. The supply chain context, obviously, just to be clear, confidential data is, as you can imagine, as everything else becomes commoditized, your knowledge, your connections, your network, your audience is very important, your community. Why not share private data? Cybersecurity, hacking, that's all a very, very large industry. In some respects, maybe in many respects, maybe in all respects, the zero-knowledge economy, ZKP, FHE can make cybersecurity software obsolete because you're never sharing data. Data is always encrypted, even locally or in your cloud, and so there's nothing to steal. But theft happens probably more than you think, even in the business-to-business context. People, show up with fake badges to pick up cargo and steal it to job sites. And it's a huge international problem in a sense, a type of maybe modern piracy, if you will. But again, having a more verifiable proof of your identity that can't be faked, but it's also kept kind of private, not just on blockchain, but maybe privately on blockchain or some kind of decentralized network, is helpful. Also, why not share private data or why employ these new technologies is artificial intelligence really blurring the line between truth and falsity, fiction and reality. And is that a real image? Has the image, even a fictional image, has it been doctored, right? So forms of verification are really important, I think increasingly so. And just not sharing data, right? If I want to work with people but not have that data end up in an AI model, we want to share it privately. And that's where FHE would come in as well. So, if knowledge is power, perhaps zero knowledge is trust. I tried to think of something that rhymed with power. I just could not find the word. And in that sense, perhaps counterintuitively, or at least maybe more realistically, all I really care about is trust, maybe perhaps more than transparency. Like, I don't need to know everything about a business counterparty or some other person I'm dealing with, as long as I can trust that certain things are true about them, their identity, whatever characteristics, their compliance with law, and so forth. And so we can achieve trust, I think, more easily, which is going to still be difficult, but I think we can achieve more universal trust, and that's part of the project of blockchain, more easily than universal transparency over everything, and of course, that's not even desirable. And that's what we're doing at ICME. The idea is to take this technology, put it in a ZK WASM implementation, so it can run more scalably everywhere. You can ask Wyatt about that. And I will say thank you very much. See you at lunch.